So, we will start with the next important topic, that is the climate. In the climate, I will first explain you the basics of the climate. लिखाऊंगा कुछ नहीं, जिनको running notes लेने हैं they can take the running notes, and then we will do the some of the topics regarding जो उस topic में आएगा. For example, we will start first with the composition and the structure of the atmosphere. So, when we look at the composition of the atmosphere, the composition of the atmosphere you already know is the gases, after that water vapor and the particulate matter, that is particulate matter 2.5 या particulate matter या what are known as the atmospheric dust particles, we will call them as, which are suspended in the air. So, because they are suspended in the air, they are known as aerosols. Fine. Now, you already know there are gases are nitrogen is the most dominant gas, followed by oxygen, followed by CO2, followed by CO2, and then there are some of the other trace elements such as krypton, xenon, methane, etc. out of which nitrogen हमारे कुछ काम का नहीं है, oxygen हमारे कुछ काम का नहीं है, argon हमारे कुछ काम का नहीं है. We know that carbon dioxide is a major greenhouse gas. Now, what is this greenhouse gas? Any gas that will trap, that is any gas that is transparent or it allows the incoming solar radiation, because it is in the form of short waves, solar radiation, but traps the outgoing long wavelength वाला, especially infrared, कौन सा? Especially infrared radiations is greenhouse gas. Fine. The importance of this greenhouse gas is, one, it makes planet Earth habitable. Why? Because it increases the temperatures on the Earth. It makes the Earth habitable. It increases the temperatures on the Earth, and therefore, it is because of the carbon dioxide that as average temperature of the Earth is somewhere around 21 degrees Celsius. Had there been absence of the carbon dioxide, कहाँ पे काम आएगा ये सब चीज़ें? ये सब चीज़ें आपको आंसर राइटिंग में वैल्यू एडिशन होगी. ऑब्वियसली मुझे नहीं लगता कि ज्योग्राफी ऑप्शनल में अब वो आएंगे, राइट अ शॉर्ट नोट ऑन द composition and the structure of the atmosphere. They will not ask you this easy questions in optional. So, absence of CO2 would have made the Earth too frigid, means too cold. Fine. Life would not have been possible on the Earth. Second importance of the greenhouse gases or carbon dioxide is, in general, the carbon dioxide is the gas that is responsible for photosynthesis, and because of the photosynthesis there is a food production on the Earth, which supports the life. We are dealing only with the carbon dioxide, right? And the third important thing about the carbon dioxide is, in the recent times, as the amount of carbon dioxide is increasing, that is the anthropogenic emissions is increasing the CO2, which has now become 0.0425% instead of original 0.03%, and therefore we have इस बिल्डिंग में ₹5.5 एकड़ बन गए तो बच्चे आ जाएंगे मेरे को, and therefore we have global warming. Fine, with the host of the factors and with the host of the interactions, जो obviously हम अभी आगे जाके पढ़ेंगे. Getting it? Then the next gas that is present is ozone. कहाँ पे है? It is not naturally occurring in the troposphere, but it is naturally occurring in the lower stratosphere. Lower stratosphere between the heights of 15 to 30 kilometers from the ground, जिसको हम कहते हैं known as ozonosphere. I guess everyone is comfortable with this. ये basic facts सबको पता है. Ozonosphere. ये natural जो ozone है, which is present in the lower stratosphere, is what is known as a good ozone. Right? Why good ozone? Because it blocks ultraviolet radiations. It blocks the UV radiations, the harmful radiations that are responsible for the skin cancers. अब recently एक किसी तो cricketer ने कहा था he was suffering from the skin cancer. So it blocks the UV radiations which are known as the skin cancer. But in the present days, that is in the present day scenario, there is increasing amount of bad ozone. What is this bad ozone? Bad ozone is the ozone that is found in the tropospheric ozone. It is the ozone that is found in the troposphere. Why is this ozone? This ozone is associated with nitrogen pollution. Is nitrogen a pollutant? Actually, nitrogen is not a pollutant, but we are increasing the amount of nitrous oxides, and therefore the amount of nitrogen is increasing in the world, and this is what is known as a nitrogen pollution. Now, what are the sources of this nitrogen pollution? The sources of this nitrogen pollution is nothing but release of different oxides of nitrogen, therefore NOx. And the sources of this nitrogen pollution are सबसे पहले vehicles. So vehicular emissions. Therefore, Gadkari says that in next 2 years, there is no need of odd even scheme, because he says that in next 2 years, that Delhi mein there will be no problem of the pollution left. Why? Because he is focusing too much on the BS6 engine norms. Getting it? But problem ये है जिनको पता है that BS6 is not going to reduce the nitrogen pollution, because BS6 will be mostly focusing on the sulfur pollutions. Gadkari, how does he say that he is going to make sure that there will be no pollution in Delhi by 2020? The same way they said that there will be no pollution in Ganga by 20 to 30%. सल्फर पोल्यूशन कम होगा 80% से, कंपैरेटिवली कम होगा, बट बिल्कुल पोल्यूशन नहीं होगा, रूल्ड आउट. दिल्ली विल बी अ टोटली क्लीन सिटी नहीं, जैसे गंगा भी क्लीन होने वाली थी 2 साल में, राइट? द सेम थिंग इज देयर. नहीं, पेट्रोल क्यों सेम रहेगा? BS obviously it is going to come by next year. BS6 fuel will be different from the BS4 fuel. Transition period, remember it is a, but transition period के साथ साथ vehicles भी बढ़ेंगे, so total zero pollution तो कभी नहीं होगा, क्योंकि उसके लिए you will have to go to electric vehicles, but obviously बहुत कम हो जाएगा pollution. It is going to see there will be large scale pollutions will be lesser. BS6 गाड़ियाँ आ रही है ना, ऑटोमोबाइल डिक्लाइन इज अ टेम्पररी फेज, इट इज नॉट गोइंग टू. दिवाली आने दो, कुछ डिक्लाइन नहीं दिखेगा इंडियंस को, कोई रिसेशन नहीं होगा. यस्टरडे आई वाज लिसनिंग टू वन एनडीटीवी का प्रोग्राम कि मार्केट्स में ये बुरी हाल है, ये है, वो है. दिवाली आने के बाद सब कुछ सही हो जाएगा. कितना कंज्यूम भी करेंगे लोग, रिसेशन तो होगा जब एक्सेस कंज्यूमरिज्म होगा. एंड सी जो सिटीज है, जो दिल्ली जैसी सिटीज है, मेजॉरिटी ऑफ द पॉपुलेशन हियर will not keep the vehicles for more than 2-3 years. वो कहीं बाहर चली जाएगी, एटलीस्ट कोई नई गाड़ियाँ आएंगी. जितना नया वर्कफोर्स आएगा, नई गाड़ियाँ आएंगी. जो पुराने इंजन्स थे उनको, उनके अंदर BS6 फ्यूल जाएगा, BS4 इंजन्स में BS6 फ्यूल जाएगा, तो ऑब्वियसली इफ जीरो नहीं तो एटलीस्ट 20%, 30%, थोड़ा तो पोल्यूशन कम होगा. इट इज नॉट, यू कैनॉट बी सो पेसिमिस्टिक. लॉजिक क्या चाहिए उसमें? They have aim. They have aim that is known as National Clean Air Program. What is the aim? 20. So you don't know the aim. Government has a aim. National Clean Air Program says that we are going to reduce the particulate matter 2.5 by 30 to 40% by 2023 compared to 2017 as a base level. Aim hai. We have aim that BS6 engines are going to reduce the pollution, sulfur oxide pollution by 80%, nitrous oxide pollution by 30%. We have aim that is green crackers. We have aim that is the energy efficient buildings. We have aim Griha index. सब कुछ एक साथ नहीं हो सकता in the governance. That is the difference. That is why बाद में जाऊंगा कि कभी भी साइंटिस्ट नहीं आने चाहिए, ब्यूरोक्रेट्स हैव टू बी देयर. गवर्नर ऑफ अ RBI एज अ ब्यूरोक्रेट मुझे ज्यादा विश्वास है रादर देन एज अ साइंटिस्ट. फाइन, जीरो या माइनस, अरे सब कुछ चलाना होता है देश में, ऐसे नहीं देयर कैन नॉट बी रूल्स लाइक चाइना. फाइन, सो बिकॉज साइंटिस्ट क्या कहेगा, इधर 0 और 100, but real life is always in between. So why IAS is the head of any department? Why not scientist? बर्बाद कर देंगे scientist. Except for ISRO, obviously because IAS को कुछ समझ में नहीं आएगा. Who is asking you? Engineers की भरमार है. There is a flood of engineers. Coming back to the vehicular emissions, coming back to the nitrous, this thing. One of the reason is vehicular emissions. The other reason is biomass burning. And this biomass burning, you can remember, it can be in the form of both waste burning या stubble burning. It can be anything. It can be any kind of an biomass. It can be waste, it can be stubble burning, or it can be forest fires. Amazon ka forest fires. It can be anything. Fine. The third reason for the nitrogen pollution is excessive use of nitrogenous fertilizers. Getting it? Excessive use of nitrogenous fertilizers. And the fourth reason for the nitrogen pollution is animal husbandry industry. Methane to hai like yesterday, but why? Because animal waste is nothing but nitrogenous waste. So animal jitna cattle rearing industry badhega, utna more oxides of nitrogen. Why I am saying this is the nitrogen pollution? Because any of this ka outcome will be excess nitrous oxides in the atmosphere. And this nitrous oxides in the atmosphere which are given, they are always converted in the presence of sunlight to ozone. And this results into the formation of tropospheric ozone or bad ozone. Ozone is a very good gas, but in the upper atmosphere. Ozone is an equally bad gas in the lower atmosphere. Q आगे का topics, fine? But understood? Understood this diagram? But kisme? Only in the presence of sunlight. So nitrogen pollution is jitna stronger is the sunlight, utna stronger is the nitrogen pollution. So can I say nitrogen pollution is particularly severe in the tropical countries like India rather than in the colder regions of the world? Getting it? अब इसको हम फोटोकेमिकल स्मॉग वो सब कहेंगे, वो आगे जाके आएगा, अभी नहीं. Then the important feature is the water vapor. And this water vapor will play a role in hydrological cycle. That is why I am doing this exercise today. You should know what is there in the syllabus and what is not there. ये दिया है syllabus में, hydrological cycle. Fine. It plays an important role in stability of the atmosphere and instability of the atmosphere. And instability of the atmosphere means nothing but formation of clouds and the types of precipitation. Stability मतलब generally dry condition. बस इतना आज के लेक्चर से you can take out कि stability मतलब generally dry conditions, and ये बहुत सारे reasons के कारण form होगा. One of the outcome is fogs of the stability. Fogs will be formed. Air ऊपर जा रही है, नीचे आ रही है, इसको हम कहेंगे unstable. Air ना ऊपर जा रही है ना नीचे आ रही है, उसको हम कहेंगे stable. So this is what is the stability and the instability of the atmosphere. If you have any doubt, you can stop and ask me. Fine. and obviously water vapor is also a important but naturally occurring greenhouse gas. It's a very, very important greenhouse gas. And then we come to the aerosols, the role of aerosols. Role of aerosols सबसे important is in the cloud formation. They help in the formation of clouds. How do they help in the formation of the clouds is this. The topic we are doing here right now will require generally around 2 to 3 classes in GS. इसलिए कोई doubt है तो मुझे पूछ लेना. Fine. There are numerous aerosols in the atmosphere. तुम कैसे आ गए आज? खत्म हो गया ओशनोग्राफी. This is, we have started with climate. So aerosols are present in the atmosphere, they are suspended in the atmosphere. Water vapor due to evaporation, that is global hydrological cycle, the water vapor due to evaporation will go up. This water will start cooling at the rate of 5.5 degrees Celsius for every kilometer or 10 degrees Celsius for every kilometer. भूल जाओ अब 6.5 degrees Celsius. So सबसे पहले निकाल दो दिमाग में से कि there is something known as environmental lapse rate. Environmental lapse rate is there, but a parcel of air which is going up and down, जो हम अभी तक GS में पढ़ते हैं, that they cool at the rate of 6.5 degree Celsius will never cool at that rate. The parcel of air, if it is dry air, it will cool at the rate of 10 degrees Celsius for every kilometer, which we will call this as dry adiabatic lapse rate. We call them as the dry adiabatic lapse rate. Fine. Or if the air is moist, या बन जाती है moist after going upwards, it will cool at the rate which is known as wet adiabatic lapse rate. Dry adiabatic lapse rate. See, obviously after geomorphology ये सब topics बहुत आसान है. ओशनोग्राफी का एक प्रॉब्लम मुझे लगता है कि ओशनोग्राफी में the topic is very easy, but if you have gone through past year questions interpret करने पड़ते हैं what they are asking. Climate में questions are direct like geomorphology. Fine. And climate is very, very interesting. Unlike geomorphology, it is very interesting. Oceanography is interesting, but उसमें बहुत सारे आपको insights मिलते हैं. हाँ, ऐसे भी होता है, वैसे भी होता है. यहाँ पे you know that these are the practical experiences. Dry adiabatic lapse rate, and obviously there is a moist या wet adiabatic lapse rate. What is this? Suppose अभी यहाँ से हवा है. There is too much heat in the Delhi right now. और यहाँ की हवा ऊपर जा रही है from the land. It is a dry air. It will cool at the rate of 10 degrees Celsius for every kilometer. Fine. ऊपर जाके उसने cloud forms किए. If it forms the cloud and it starts giving the rainfall, that air has become moist. And उसके बाद भी if the air is going up due to a mountain barrier or due to anything, it will now start cooling at the moist adiabatic lapse rate. So then what is environmental lapse rate? जो अभी तक हम पढ़ते आए हैं, which is equal to 6.5 degrees Celsius for every kilometer. What is also known as normal lapse rate. What is that? That is nothing but कि if this is in my individually ground, ये मेरा sample ground है, in this ground अगर आप यहाँ पे हो, air is not moving, you are moving, so 1 किलोमीटर ऊपर जाने के बाद कितना temperature decrease होगा? और 1 किलोमीटर जाने के बाद कितना टेम्परेचर डिक्रीज होगा? दैट इज इन द स्टैटिक एयर. इफ द ऑब्जेक्ट इज गोइंग अप एंड डाउन, it will always experience cooling by the rate of environment, but the air parcel itself will always cool at the rate of dry and wet adiabatic. Means if यहाँ की air is static, means it is stable air, and यहाँ पे temperature is 30 degrees Celsius, you are here, by some mechanism if you come here, यहाँ पे the temperature will be 23.5 degree Celsius. That is what is the environmental lapse rate. और ऊपर जाओगे तो -6.5. Getting it? But if you are constant, और आप अभी आपको भूल जाओ, यहाँ की हवा है, and this air will start rising upwards by Ekman's spiral. वो cool करेगी either by the dry adiabatic lapse rate or by moist adiabatic lapse rate या wet adiabatic lapse rate, whatever it is written. And the relationship between the dry adiabatic lapse rate and the moist adiabatic lapse rate determines the stability and the instability of the atmosphere. And this is the second part of our syllabus, stability and instability of the atmosphere. That is, we are expected to know this dry and the moist adiabatic lapse rate. Understanding the difference between environmental and the dry moist adiabatic lapse rate? नहीं. Suppose you are in the rocket and आप ऊपर चली गई, हवा वैसे ही है, हवा नहीं ऊपर जा रही है, so the temperature is going to decrease by 6.5 degrees Celsius per kilometer. Fine. But the air, if it is going upwards and downwards, उसका temperature decreases by dry and moist adiabatic lapse. देखो, you will understand with this example. This is a parcel of air X, जिसका temperature is 30 degrees Celsius, same as the temperature of the surrounding region. It is going upwards. As it is going upwards, it will cool. Initially, will take by the dry adiabatic lapse rate. So, ऊपर जाने के बाद, what will be उसका temperature? It will be 20 degrees Celsius. If it cools by the dry adiabatic lapse rate. Understanding? Understanding now? 20 degrees Celsius, is it cooler than the surrounding region or warmer than the surrounding region? What it is? This parcel of air, is it cooler than the surrounding region? Surrounding region mein what is the temperature? 23.5. This parcel of air ka what is the temperature? 20. So which is cooler? The parcel of air. Cooler matlab denser या heavy, lighter. Cooler means denser. So और ऊपर नहीं जाएगी, वो नीचे आएगी. Stability. Getting it? This is what is the stability. But if it goes up by moist adiabatic lapse rate, so minus 5.5, how much it is? 24.5 degrees Celsius. Environment का कितना है temperature? 23.5. इसका कितना है? 24. Means it is warmer. That means lighter. ये और ऊपर जाएगी. And that is what is known as instability. Clouds कौन से हवा बनाएगी? ये हवा clouds बनाएगी. जितना ऊपर जाएगी उतना वो ठंडी होती जाएगी. And this will result into formation of clouds. Getting it? Obviously, this is the most simplistic explanation. इसमें there is mechanical instability, there is a forced instability, there is instability, etc. But understanding the difference? So when the air is going upwards, you will understand that it will start cooling by the wet or moist adiabatic lapse rate, and therefore water particles, water vapor will get converted into water droplets. And this water droplets, because it is a liquid या solid matter या ice, उनको कुछ तो एक resting place चाहिए. जैसे हवा को इस रूम में resting place नहीं चाहिए, but water requires a resting place. Ice solid will require a resting place. and this resting place is provided by the dust particles which are known as hygroscopic nuclei or cloud condensation nuclei. Why they are known as the cloud condensation nuclei or the hygroscopic nuclei? Because if the ice particles are formed, उसी aerosols को हम कहेंगे cloud condensation nuclei. If the water particles are formed, उसी aerosols को हम कहेंगे hygroscopic nuclei. Hygro means water. Fine. So they will help in the formation of small cloud droplets. Will help in the formation of the smaller cloud droplets. This smaller cloud droplets will collide with each other as the air will blow, and after collision they will start becoming bigger in size. This process is known as coalescence. जैसे pediment zone में by the coalescence of pediment king का pediplane बना था. So by the coalescence, collision and the coalescence of cloud droplets, bigger clouds are formed. As the bigger clouds are formed, the cloud becomes so big and heavy that it will start falling as either rain or snow. Fine. So what is the role of aerosols? The role of aerosols is first, they act as cloud condensation nuclei or hygroscopic nuclei and help in the formation of clouds. अब कैसे clouds बनेंगे? Understood this process? That depends upon whether where you are. If you are in the temperate regions, that is formed by Bergen-Bergon process. मतलब एक थियरी है, थियरी ऑफ क्लाउड फॉर्मेशन. Fine? Collision coalescence theory. And if you are in the this is what is the ice crystal theory of the cloud formation. And if you are in the other subtropical region, there is a normal theory of the cloud formation. Fine. So यहाँ पे दो theories आ जाएंगी in the process of cloud formation. कुछ नहीं, यही theories हिंदू के articles verticals में आती है. The only thing is they don't write the name of the theories, and इसीलिए वो articles पढ़ने में कभी-कभी difficult होता है. But once you understand these theories, you will understand what that article is trying to say. कब आता है ये article? ये article तब आता है जब when you read that increasing pollution due to aerosols is reducing the process of cloud formation. So Hindu कहता है कि there are less ice crystals, super cooled water droplets in the sky, and because of this the super cooled water droplets split into different parts, resulting into smaller cloud particles, resulting into no cloud formation. So कुछ नहीं, यही theory है. Now इस theory का एकदम simple words is, so aerosol pollution results into decrease in the cloud formation. ये see in the normal cases water particles will rest along the aerosols and they will collide and they will result into formation of bigger clouds. जितना बड़ा clouds उतना हवा उसका वजन नहीं उठा सकती, air can no longer hold them in suspension, they will start falling down as rain. Now imagine if the amount of aerosols increase in the atmosphere. In this case, it will have two impact. सबसे पहले it will reduce the evaporation. Why? Because now it will block the sunlight. And secondly, even if the evaporation is occurring, the water droplet which used to rest on this cloud, a single water droplet, now this water droplet will split between large number of aerosols. Understanding? जो पहले बड़ा water droplet बनना चाहिए था, it will get split and small water droplets बनेंगे. Now this small water droplets to become very big clouds, they will have to collide with each other and then they will become a large cloud. But because ये छोटे हैं water droplets, sun rays इसको easily evaporate कर देता है. And because the sun rays इसको easily evaporate कर देता है, तो क्या नहीं होता? No cloud formation. Getting it? And third thing, what the aerosols result into is the global cooling, because it blocks the sunlight. Now just open your syllabus once. What we have studied right now is nowhere mentioned in our syllabus directly. That is, unlike GS, कहीं पे भी mention नहीं structure and the composition of the atmosphere. Directly हमारा शुरू होता है syllabus temperature and pressure belts of the world से. Second है heat budget of the earth से, a mathematical equation just like heat budget of the oceans. Third है atmospheric circulation, which is in the form of winds and the jet streams. Jet streams are nothing but the winds which flow on the height of 10 to 14 kilometers. Wind is horizontal movement of the air on the ground. What is wind? Horizontal movement of the air on the ground, not vertical. Fine. फिर जो मैंने अभी कहा था atmospheric stability and instability, and then winds को इन्होंने different ways में classify किया है. Trade winds, jet westerlies, easterlies को they will call them as the planetary winds. Then local winds are there, Chinook, Fawn, etc. Then we have the monsoon winds and the jet streams. Lastly, we have the air masses and the frontogenesis. What are the different air masses? Out of that, जो भी आप GS में पढ़ते हो, as it is, it applies here. There is no difference in the study of GS and in the study of this thing, except theories of the cloud formation जो extra आ गई यहाँ पे, and except air masses. So circle air masses. Air masses is one topic which is asked in detail in optional. In GS, those who have done, you know there are two kinds of air masses, continental and polar air masses. Fine. अब यहाँ पे वो पूछेंगे, write a short note on continental polar masses of North America, continental tropical masses of South America. मतलब they will go specific region wise. Temperate and tropical cyclones, ये भी same है. Types and the distribution of precipitation, there are three types of precipitation: convectional, orographic and cyclonic. Fine. Distribution of precipitation worldwide, Mediterranean type of climate में क्या है, equatorial type of climate में क्या है, यह ये भी same है as it is GS. And then after that starts the real optional, that is the Köppen, Thornwright, Trevartha classification of the global climates. Theory building, the impact of quantitative analysis and systems analysis in geography, in which we try to make general laws of geography which can apply universally to all the region. So Trevartha ने कहा हाँ वर्ल्ड के क्लाइमेट्स इतने टाइप के हो सकते हैं, जनरल लॉ है, फाइन. सेम कोपन ने कहा, सेम इसने कहा. So basically you study this climatic types of Köppen. You study the climatic types of Köppen in GS also. The only thing is you don't know that it is the Köppen's climatic type. Those who have studied the last 10 chapters of GC Leong, equatorial type of climate till the tundra type of climate, क्या है ये? Köppen का ही classification है. The only thing is they have not written the word Köppen in it. Getting it? जो लास्ट 10 चैप्टर्स है जीसी लियोंग के वो कोपेन ही है. ऑब्वियसली थॉर्नवाइट कोई नहीं पढ़ता बिकॉज थॉर्नवाइट इज द ब्रदर ऑफ टेंक, मतलब नॉट द रियल ब्रदर बट थियरी बिल्डिंग में ही इज द ब्रदर ऑफ टेंक. एग्जैक्टली राइट. बट जब कोपेन एंड थ्रेवार्था विल से दैट हाँ देयर आर मैक्सिमम 15 टाइप्स ऑफ क्लाइमेट, थॉर्नवाइट सेज नो 148 टाइप ऑफ क्लाइमेट आर देयर. गेटिंग इट? रियलिटी इतने ज्यादा क्लाइमेटिक टाइप की वर्ल्ड मैप में नहीं बन सकता उसका. And geography without world map is useless. Fine. So Köppen का है सिर्फ theoretical interest, थॉर्नवाइट का है सिर्फ theoretical interest. Hydrological cycle and then उसके बाद फिर से general topics, global climate change and the role of the response of the man in the climate change and applied climatology and urban climate. But यहाँ पे just like geomorphology and unlike oceanography एक एक वर्ड को उठाना पड़ेगा एंड यू विल हैव टू अंडरस्टैंड. टेम्परेचर दिया है, आई एम जस्ट टेलिंग यू हाउ द क्वेश्चंस आर आस्क्ड एंड कम टू द क्वेश्चंस ऑफ द क्लाइमेटोलॉजी. सिर्फ टेम्परेचर दिया है, बाकी कुछ नहीं दिया है. बट लुक एट द क्वेश्चन ऑफ 2016. Differentiate between insolation and temperature and explain anomalous temperature या anomalous temperature. So nowhere in the syllabus insolation is given, but you study that in GS. Obviously we are going to study here because ये इतना आसान question हाथ से नहीं जाना चाहिए because you don't have words. Anomalous temperature या anomalous temperature is obviously it is very, you already know anomalous temperature. The only thing is maybe ये word पता नहीं है. Europe, UK, fine. Africa, it is located at some latitudes. Maybe can I say the latitude is between 55 degree north to 60 degree north, fine. यहाँ पे समर का टेम्परेचर कैन आई से शुड बी 18 डिग्री सेल्सियस एंड विंटर का टेम्परेचर शुड बी लेस देन 0 डिग्री सेल्सियस. बट इन द नॉर्थ वेस्ट यूरोप, दैट इज ये जो जितना भी शेडेड पार्ट है विच इंक्लूड्स यूके एक्सेट्रा, समर टेम्परेचर इज समवेयर अराउंड 21 डिग्री सेल्सियस, विंटर टेम्परेचर इज समवेयर अराउंड 5 डिग्री सेल्सियस. दैट इज हायर देन नॉर्मल. क्यों? हमने किया है ये ड्यू टू द वार्मिंग इफेक्ट ऑफ द ओशन करंट्स. सो दिस इज एनामोलस टेम्परेचर. एक लैटिट्यूड पे अगर बहुत ज्यादा वेरिएशन है ऑफ द टेम्परेचर ड्यू टू सर्टन रीजंस, दैट इज व्हाट इज नोन एज एनामोली. एनामोली मीन्स डिविएशन फ्रॉम नॉर्मल. जैसे हम अंदर अंदर जाएंगे इन रशिया, इन द साइबेरिया रीजन, यहाँ पे विंटर टेम्परेचर बिकम्स and summer temperature becomes at the same latitude. क्यों? Because जितना अंदर है, जितना it is far away from the sea, उतना during the summer season this land will get heated. There will be no redistribution of the heat because it is not near the coast. Equatable climate नहीं है. जितना it is interior, उतना during the winters it will become cooler, and therefore this is also an thermal anomaly. So two examples of anomalous temperature. Getting it? Fine. So this is very direct. You already know what is the difference between insolation and temperature. And मुझे लगता है basic idea of cyclones, cyclones तो पता ही है आपको, right? So with this background, any doubt till now? Aerosols? We are going to start with the first topic. Hmm? Climatology, yes, Savindra Singh. Only for geomorphology, that Savindra Singh is not sufficient. Baki every topic ke liye Savindra Singh is more than enough. Physical geography. If you want to buy some special book on climatology, there is. ठीक है. So tell me, what is the difference between weather and climate? See, we say the best book on climatology, if anybody is planning to buy, is Atmosphere, an introduction by Ludgens and Tarbuck. If you buy it, मेरे को भी एक xerox copy दे देना. Fine. Tarbuck and Ludgens. So we will download it and share it. ऐसा कोई जरूरत नहीं. You see, foreign books की कोई जरूरत नहीं है. Unless एक हर topic है जो कल के जैसा था, which is a very generalized topic, because our syllabus is designed as per Indian universities. So हमारे लिए Savindra Singh is more than enough. DS Lal if you want it for reference. वैसे कोई जरूरत नहीं पड़ती. खरीदना है तो extra book खरीदो, रूपा made simple, rather than buying DS Lal or buying the geomorphology by Savindra Singh, by Rupa made simple, both physical and economic, both. They are very old. Data is not, the concepts are same, data has changed. Concepts are same. Only in the economic geography. Why I am saying Rupa made simple? Because Rupa made simple, you should just read it the year you are writing the exam. मतलब एक बार पूरे की पूरी ज्योग्राफी पढ़ ली, सारे टेस्ट सीरीज दे दिए, उसके बाद लास्ट मोमेंट पे रूपा मेड सिंपल पढ़ो. रूपा मेड सिंपल के बाद आपकी लैंग्वेज खुद ब खुद सुधर जाएगी. You will write it in a much better language, and that book will make the difference between 270 to 300. वो बुक आपको 270 देगा नहीं, 270 तक आपको मेहनत करनी है. वो बुक है सिर्फ वैल्यू एडिशन के लिए. डिफरेंस बिटवीन कोरल कोस्ट एंड द लो एनर्जी कोस्ट कहीं नहीं दिया है, सिर्फ वहीं से है. सूडो वॉल्केनिक फीचर कहीं नहीं दिया है, सिर्फ वहीं से है. एक हाथ क्वेश्चन. फाइन. एंड द लैंग्वेज दे हैव रिटन. The authors, that book has not been reprinted since, not been changed since 1980, but still it is a very good book. और अभी भी आपको कुछ समझ में नहीं आएगा वो book till the time you don't have mastered the subject. It is nothing but Rupa made simple is basically the difference between Lakshmikant and D.D. Basu. Constitution दोनों में ही है, but still D.D. Basu is the classic. Getting it? No need of buying any of that book. उससे अच्छा इंडियन ज्योग्राफी की दो खरीद लो. खुल्लर जो सब रेकमेंड करते हैं, माय फेवरेट इज आरसी तिवारी. आरसी तिवारी का इजी लैंग्वेज का चेंज, मतलब तिवारी को किसी ने अगर इजी लैंग्वेज में लिखा है, मतलब माजिद हुसैन सर की बुक. फाइन. So Indian geography by Majid Hussain is nothing but a simplification of R.C. Tiwari. R.C. Tiwari is a very good book. And if you ever go to the Daryaganj ka old Delhi ka market, you will find the best book on Indian geography, that is Mamoria, Indian Economic Geography. But Indian Geography के 2 book होने दो, rather than buying DS Lal, Khullar, etc. Means, and those who are saying कि sir आपने कहा था कि books की ज़रूरत नहीं है, ऐसा नहीं है. Notes are obviously more than enough, but you should have a book for reference. You should always have one book for reference. Fine. So basic difference between weather and climate is a daily phenomena which can be measured by different instruments. Climate is an integration of the weather minimum for 25 years. Minimum for 25 years. Understanding? Not that some days ka weather becomes a climate. So weather changes on the daily basis, but whenever the climate starts changing, it is an indication that either it is anthropogenic for a long term or either it is natural by Milankovitch cycles. Weather will always keep on changing. So weather may the summers can be warm than the previous summers, the winters can be cold than the previous summers. But agar summer started becoming warmer from 1970s, तो फिर 2010 में आके ये कहेंगे कि the climate change has occurred. Fine? And even in the climate change, में the average temperature of the earth will be increasing due to global warming. But this average temperature में अगर पहले summers is around 35 degrees Celsius, यहाँ पे summers can become 45 degrees Celsius. पहले if the winter का temperature is around 20 degrees Celsius, winter का temperature can become around 15 degrees Celsius. कितना हुआ? कितना हुआ? कहाँ पे हो रहा है global warming? Getting it? So, अगर winters are becoming more severe, then also it is an indication of global warming, because winters is an indication of weather change. Summers are becoming more severe, winters are becoming more severe, but पूरा average of temperature of the earth, annual average temperature of the earth किसमें ज़्यादा बड़ा है? इसमें. So this is what is the global warming. This is why some students get confused कि इस साल सर्दी तो बहुत ज़्यादा है. सर ने लिखाया था कि during the global warming there will be more severe winters. ऐसे कैसे global warming? जब मैं लिखाता हूँ that it is the more severe winters, it means weather change, does not mean climate change. Getting it? Understanding? Everyone? So 2-3 basic lines regarding the weather and the climate. वो भी इसलिए because it is given in the syllabus. Otherwise, weather and the climate are the two scales of the measurement of the atmosphere. Are the two scales of the measurement of the atmosphere. Of the measurement of the atmosphere. Weather denotes day-to-day or short-term state of the atmospheric variations. Weather denotes day-to-day or the short-term state of atmospheric variations. Short-term state of the atmospheric variations, and it is measured in the terms of temperature, humidity, precipitation, visibility, etc. Visibility, humidity, winds, जो कुछ लिखना है लिखो, cloudiness, etc. ये सब किस में आएगा? Weather में. You cannot determine the cloudiness in climate. आप नहीं कह सकते कि whatever is your birth year उस समय कैसा cloudiness था versus 2019. You will determine it only on the basis of today and tomorrow. Getting it? Weather and weather forecast is more of a practical influence is more of a practical importance why I am making you write is not जो हमने लिखा है अब तक यहाँ से important है and hence weather forecasting involves one, observation tools and analysis tools. And analysis tools मतलब एक जिससे आप ऑब्जर्व करते हो डेली फिनोमेना, एक जिससे आप एनालिसिस करते हो. When you build up the analysis tool, integrate the analysis tools and ultimately come to conclusion for 25-30 years, उसको हम कहेंगे climate. Understanding? The observation tools include Doppler radar, weather stations, and buoys. Third, radar network. Ships and airplanes, as well as fourth, ships and airplanes. Fifth, drop zones. What is drop zones? Sixth, satellites. You know what is weather stations? What are the BOs? सी में क्या? यस, शिप्स में कभी कभी सी में प्लास्टिक के कुछ फ्लोटर्स लगे रहते हैं. दिस आर व्हाट आर नोन एज BOs. उससे क्या पता लगता है कि कितना सी लेवल राइज हुआ, कितना फॉल हुआ, कौन से सीजन में राइज हुआ, टेम्परेचर अगर ज्यादा है, अगर ज्यादा वॉल्केनिक इरप्शन है. सो सपोज देयर इज अ माउंट क्राकातोआ व्हिच इज फेमस फॉर वॉल्केनो, उसके ऊपर ये लगाया रहेगा. If the volcanic eruption has increased, if the heating of the earth has increased, Will the ocean water there increase heat? Because of heating it will increase. फट से सबको बोलेंगे कि देखो माउंट Krakatoa has a chance of becoming active. Be ready for tsunami anytime if in case it happens. Understanding? Radar network, very simple. कि radar network क्या है? Network of radars. What are radars? It is nothing but a device that will look at, his answer is microwave device that will look at a location. यहाँ पे it is a microwave device that will record the cloud formation, changes in the cloud formation, rainfall की intensity, heat budget of the earth, coming up of monsoon, going away of the monsoon, the position of the ITCZ. That is हमें ये सारे points use करने in the prediction of Indian monsoons. Fine. What is drop zones? There are many places जहाँ पे आप जा नहीं सकते. Maybe it is located in the interiors of the Himalayas, but वहाँ पे temperature क्या है? Or maybe it is located in the stratosphere. Maybe it is located in the mesosphere. How do we know वहाँ पे temperature कितना है? Balloon के साथ thermometer will be suspended. It will be connected by some method to the earth, and that balloon will go there. So वो balloon will go and drop in that region. उसमें कैमरा फिटेड होगा या उसमें थर्मोमीटर फिटेड होगा. जैसे फॉर एग्जांपल विक्रम रोवर जब वो किसी और पे जाता है मून पे, वी विल कॉल दैट एज अ रोवर. व्हेन द बलून इज अटैच्ड एंड इट गोज ओनली इन द रीजन्स व्हिच आर इनएक्सेसिबल टू द ह्यूमंस एंड इट विल सेंड उसका लोकेशन, इट इज नोन एज ड्रॉप zones. फाइन. व्हाट इज डॉपलर रडार एंड वेयर इज उसका यूज? What is Doppler effect? In simple words, Doppler will detect what? किसके? लाइट या साउंड का शिफ्ट देखेगा. लाइट या साउंड का शिफ्ट कब होता है? जब क्यूमुलोनिम्बस क्लाउड्स बनते हैं, जब देयर इज अ हेवी लाइटनिंग एंड थंडर. So if there is a heavy lightning and thunder, it will shift. Fine. In case there is a heavy lightning and thunder, the Doppler will shift, and if the Doppler shifts, that means कहीं तो ऊपर पहाड़ों में heavy lightning and thunder हुआ है, इसका मतलब बादल फटे हैं और cloud burst हुआ है. इसका मतलब जो नीचे के areas है, they should be prepared for floods. Understanding? Doppler radar is a very simple thing जो इंडिया में 2013 तक नहीं थी. इसलिए उत्तराखंड ट्रेजेडी हुई. नहीं तो उत्तराखंड ट्रेजेडी 2 दिन पहले पता लगती कि अगर वहां पे डॉपलर्स होते. डॉपलर्स क्यों नहीं थे? डॉपलर्स इसलिए नहीं थे क्योंकि पॉलिसी नहीं थी, ऐसा नहीं है. डॉपलर्स थे, सरकार ने सारे डॉपलर्स लिए थे और लेके वहां पड़े हुए थे. इंस्टॉलेशन 2 साल से टला हुआ था. व्हाट हैपेंड? उत्तराखंड डिजास्टर. क्यों टला हुआ था? ह्यूमन नेचर, चीजें पोस्टपोन करने, एडमिनिस्ट्रेशन नेचर, चीजें पोस्टपोन करने. आफ्टर दैट वी हैव मेड इट कंपल्सरी दैट द स्टेट गवर्नमेंट्स will install Doppler in all the mountainous regions so that at least they cannot prevent the landslides, but they can save the lives. They can move the people from the region. Getting it? Understanding? So first, Doppler radar. Doppler radar is used to determine wind direction, speed, comma, thunderstorms, as well as what did I write? Thunderstorms, as well as intensity intensity and the strength of the rainfall. Intensity and the strength of the rainfall. Intensity and the strength of the rainfall. See, human nature क्या है? सर्च, ये ऑफिशियल लैपटॉप है. Next, the Doppler, the waves, the Doppler waves are reflected by something moving away. The Doppler waves are reflected by something moving away. Or moving towards the antenna, moving away or moving towards the antenna. And by this we can predict, the landslides, sorry, we can predict the thunderstorms, cloudburst in the regions which are very far away from human habitations, We are very far away from the human habitations. We have a look at the very quick video.
My name is Kite. I work here at the Met Office where I manage the Weather Radar network. I'm going to be talking to you today about weather radars, how they work, and how we make use of the data. So why do we have weather radars? Well, radar stands for radio detection and ranging. In 1935, Robert Watson Watt patented the first radar system, which aimed to locate enemy ships and aircraft if and when war broke out. It was soon realised these instruments were sensitive enough to measure precipitation, and weather radars were born. Radars use an echo sounding technique. They use the same...
Understanding? Doppler, they will, if there is a rainfall, the waves will hit and they will be reflected back. So इससे आपको पता लगता है either there is a heavy rainfall, snowfall. जितना ज़्यादा rainfall, snowfall is heavy, उतना fast the echoes will be. जितना light it is, उतना there will be gap, and उतना कम इससे the echoes will be. Getting it? पहले they used to work only on the sound waves. Now they use the electromagnetic waves also.
Antenna sends out a pulse of electromagnetic energy and receives a return signal. A narrow beam of energy is sent out and travels at the speed of light until it hits the target. The more reflective the target is, the greater the return echo. The distance between the target and the radar can be worked out from the time taken for the pulse to travel there and back. Water droplets and rain are really good targets because they're excellent at reflecting radar signals. The more intense the rainfall, the more water droplets are present and the stronger your return. Processing at each radar site, as well as here at the Met Office, works to convert the strength of these return signals into rain rates, which gives us the radar data and forecasts that we see every day. Different colours in radar data indicate the reflectivity of the rain. Reds indicate a strong return.
This is what you see in Hindu या any newspaper on daily basis. They are nothing but the reflectivity. ज़्यादा reflectivity मतलब ज़्यादा clouds. Fine? कम reflectivity blue color मतलब कम clouds, कम chances of rainfall. This is how it is used in the daily weather patterns.
Droplets are present, which indicates heavy rainfall. Blues signify weaker return and much lighter rainfall. The Met Office weather radar network consists of 15 radars located throughout England, Wales, Scotland,
ये इंग्लैंड का है. We are not concerned with this.
collects data out to 255 kilometers. Radar come in all shapes.
Right? Now, why this is important is because 6 hours afterwards, the cloud burst, the Bhagirathi started flowing like a flood. 6 hours afterwards वो केदारनाथ के बाद बारिश हुई। अगर डॉपलर होता तो पता लगता कि जैसे जैसे क्लाउड्स नीचे की तरफ आ रहे हैं। हमारे पास डॉपलर नहीं था, इसलिए हमारी यात्रा चल रही थी। गेटिंग इट? सो नेक्स्ट पॉइंट, डॉपलर रेडार्स are now used in the cloud burst disaster management. Cloud burst disaster management in the Himalayan regions. In the Himalayan regions. Because a radar is used to determine the weather conditions even in the far off locations. It's used to determine the weather conditions even in the far off conditions. Far off conditions. Even in the far off conditions. Getting it? In the far off regions, not the conditions, in the far off regions. 255 किलोमीटर को सबका रेडियस होता है. When a single is Doppler radar, obviously there is a network, so radar network. So fine with this? Weather station and bureaus. This record the weather parameters at the fixed locations. This record the weather parameter at the fixed locations. Buoys are present in oceans and lakes. Oceans में obviously seas भी आ गए. Oceans and lakes to measure water temperature. Measure water temperature, height of the sea level or height of the water level, including waves, and generally are used in cyclone and tsunami disaster management. They are used in cyclone and tsunami disaster management. समझ में आया कैसे cyclone and tsunami disaster management? They are used in cyclone and tsunami disaster management. Water level, waves, temperature in the seas and the oceans, and used in cyclone and tsunami disaster management, because before tsunami and before cyclone sea का temperature ज़्यादा हो जाएगा. Fine? So depression कैसे develop हो रहा है in the Bay of Bengal region etc. is recorded by the bureaus. Fine? Next, drop zones. समझ में आया? Far away locations, fixed locations. Fine? No doubt here. Drop zones collect information across the atmosphere. Across the atmosphere. When they are dropped from balloons or planes. When they are dropped from balloons or planes. ड्रॉप zones मतलब प्लेन से जा रहा है उसको छोड़ेंगे नीचे. सो मुझे बताओ वो किस में ज्यादा हेल्प करेगा, हॉरिजॉन्टल एटमॉस्फेयर में या वर्टिकल एटमॉस्फेयर में? ड्रॉप zones वर्टिकल. ट्रोपोस्फियर का टेम्परेचर कितना है, स्ट्रेटोस्फियर का कितना है, क्यों ओजोन है, कैसे पता चलता है ओजोन है, ये सब ड्रॉप जोन से पता लगता है. अंडरस्टैंडिंग? सो दे आर यूज्ड इन वर्टिकल स्टडी ऑफ द एटमॉस्फेयर. वर्टिकल स्टडी ऑफ द एटमॉस्फेयर. शिप्स एंड एयरप्लेन्स को हम कहेंगे इन क्लाइमेटोलॉजी एज मूविंग वेदर स्टेशंस, बिकॉज जहां जहां जाएंगे वहां का हमें वेदर पता लगेगा. नथिंग नॉट मच इंपॉर्टेंट फॉर एग्जाम. मूविंग वेदर स्टेशंस. In the ships and the airplanes only, okay, in the same point of ships and the airplanes. The mapping of the Indian Ocean, the mapping of the Indian Ocean, during the experiments such as MONEX, monsoon expedition, fine, MONEX has given us a understanding of, the understanding of Indian monsoons, has given us the understanding of the Indian monsoons. Understanding why predicting monsoons again is difficult, because इसके लिए आपको सिर्फ इंडिया का डेटा नहीं, पूरे इंडियन ओशन का डेटा, whether it is in the northern hemisphere or southern hemisphere, then you will have to correlate. सबसे पहले you will have to collect with the help of these things, and satellites तो you already know what is the work of satellites, right from the clouds, rain, floods, droughts, cropping pattern, forest fires, कुछ भी देखो with the help of satellites, right? So these are the methods to measure the weather conditions. इसमें से एक दो भी अगर याद रहा तो भी चलेगा. But Doppler is very very important because it is the most commonly used. That is why I showed you the video. दूसरा buoys are very important, and तीसरा the satellites. They have become very very important. अब कोई MONEX जैसा experiment करता नहीं है, but it is the MONEX experiment which discovered Indian Ocean dipole. जो मैं हमेशा कहता रहता हूँ Indian Ocean dipole, El Nino, that was all discovered by the MONEX expedition. Koteshwaram. The name of a scientist is Koteshwaram. Next line. When the weather conditions with the help of tools, sorry, मैंने सिर्फ आपको ऑब्जर्वेशन टूल्स बताए, राइट? एनालिसिस टूल्स. व्हाट आर द एनालिसिस टूल्स जिससे आप एनालिसिस कर सकते हो वेदर कंडीशंस का? वेदर को कैसे एनालिसिस करोगे सिस्मोग्राफ से? बहुत ही सिंपल है एनालिसिस टूल. एक एग्जांपल ले रहा हूँ, changing pattern of rainfall in last 20 years. So what is the analysis tool? Map. Fine. Analysis tools is first is maps. Maps can be used for both systematic study of weather patterns as well as aerial differentiation. Systematic study as well as aerial differentiation. Don't get afraid by these words, ये हमारे syllabus के ही words है. Systematic geography is the study of geography as a whole. Geomorphology, climatology, oceanography, ये है systematic geography. जब आप systematic geography को break करते हो as per regions, उसको हम कहते हैं regional geography. Geography of Asia, geography of India, geography of Tamil Nadu, geography of North India, वो है regional geography. और रीजनल ज्योग्राफी को स्टडी करने के बाद जब आप कंपेयर करते हो ज्योग्राफी ऑफ इंडिया वर्सेस द ज्योग्राफी ऑफ यूएसए और उससे कुछ कॉमन पॉइंट्स निकालते हो, इट इज नोन एज एरियल डिफरेंशिएशन. मतलब इसका मीनिंग इज वेरी सिंपल. मैप्स कैन बी यूज्ड टू स्टडी बोथ द जनरल ज्योग्राफी, वर्ल्ड ज्योग्राफी एज वेल एज रीजनल ज्योग्राफी. उसी को मैंने थोड़ा कॉम्प्लिकेटेड वे में दिया है सो दैट यू गेट फेमिलियर विद द वर्ड्स. सिस्टमैटिक ज्योग्राफी इज complete geography. Aerial differentiation is regional geography. Fine. From systematic study as well as aerial differentiation in both temporal and spatial pattern, in both temporal and spatial pattern by using isobars, isotherms, isoheights, isotachs, etc. बस इन चार चीजों का पता होना चाहिए. आइसोबार्स प्रेशर, आइसोथर्म्स आइसोहाइट्स रेनफॉल, आइसोटैक्स wind speed. Isohells sunshine. And second analysis tool is computers. रिकॉर्ड के थ्रू, यस. और इसी से हमें क्लाइमेट, मतलब हम धीरे धीरे क्लाइमेट की तरफ शिफ्ट हो रहे हैं. कंप्यूटर्स विद द कमिंग अप ऑफ systems approach and quantitative revolution and quantitative revolution. क्वांटिटेटिव मतलब क्वांटिटी, मतलब डेटा, उसको कैसे यूज किया गया, रिवोल्यूशन कैसे यूज किया गया, कंप्यूटर्स। फाइन, क्वांटिटेटिव रिवोल्यूशन इज नॉट पॉसिबल विदाउट कंप्यूटर्स। नहीं तो डेटा आपके कुछ काम का नहीं, इतना ज्यादा डेटा अब उसको एनालिसिस करोगे, मैथमेटिकल मॉडलिंग करोगे, हु कैन डू इट, ह्यूमन ब्रेन? नो, इट इज डन बाय कंप्यूटर्स। फाइन, उसी को हम कहते हैं क्वांटिटेटिव रिवोल्यूशन या सिस्टम्स एनालिसिस। विद द कमिंग अप ऑफ सिस्टम्स अप्रोच और and quantitative revolution in geography, the role of computers increased. Role of computers increased, which can study, full stop, full stop. These computers can study both the weather as well as climate of an regions, with higher accuracy, with higher accuracy. Next point, when the statistical weather information is integrated for a particular time interval, usually 30 years, it is known as climate. Does the climate determines or describes average weather pattern? Average weather pattern क्या है? एवरेज वेदर पैटर्न, अंटार्कटिका इज हॉटर कोल्डर देन इंडिया, एवरेज वेदर है ये। फाइन, या यूरोप इज कोल्डर देन इंडिया, ये है क्लाइमेट। वेदर क्या है? हीट वेव्स इन यूरोप आर वेयर हॉटर देन इंडिया, दिस इज वेदर। इस साल एक एक्सेप्शन था, बट क्लाइमेट क्या है? इंडिया इज अ मॉनसून टाइप ऑफ क्लाइमेट, यूरोप हमेशा इंडिया से ठंडा होगा। उसमें कोई ये नहीं कहेगा क्योंकि इस साल हीट वेव्स थे इसलिए यूरोप गर्म रहना शुरू हो गया। फाइन, दैट इज द क्लाइमेट। Climate is used to determine large scale weather patterns in the terms of years, decades, or also geological ages. Any change in the average climatic conditions, after analyzing weather patterns, is known as climate change. क्लाइमेट चेंज दो टाइप के होते हैं, लोकल या ग्लोबल। ग्लोबल मीन्स which is acting across the world. Because of the global climate change which is caused due to the greenhouse gas emission, हम कह रहे हैं टेम्परेचर बढ़ रहा है, इसलिए ग्लोबल वार्मिंग। ग्लोबल वार्मिंग इज एन आउटकम, क्लाइमेट चेंज इज अ फिनोमेना। फाइन विद दिस? Getting it? Question: differentiate between weather and climate. What are the tools available to study climatic patterns? The tools which are available for weather patterns are also the tools for the climate patterns. The only thing is data को जब हम इकट्ठा करेंगे they are the climate patterns. Clear here? मतलब बच्चों जैसा नहीं है वो. वेदर क्या है जो हम जीएस में पढ़ते हैं 25 साल के लिए, डेली ऐसे आंसर मत लिखने दो, आंसर प्रॉपरली एनालिटिकल लिखो. We are going to study 4 topics in this: insolation and its factors, temperature and its factors, temperature inversion and the types of inversion, and anomalous temperature. Fine. So break down your syllabus and ये 4 अगर topics ready है तो फिर you can write any answers on this. Can I continue? Coming to insolation. What is insolation? Again, don't write anything till the time I ask you. You are free to take the notes. What is insolation? Insolation is nothing but incoming solar radiation. Kitna amount of sunlight comes from the earth is what is known as an insolation. This incoming solar radiation, if you know the law which is known as Planck's law. What does the Planck's law says? Abhi exam mein mat likho Planck's law. The Planck's law says that any kind of an उसको बोलना क्लास खत्म हो गई. मनु को नहीं करना होगा काम, बोल दिया क्लास के बाद आ जाए. So Planck's law. What does the Planck's law says? Planck's law says that any region which is any body which is having a higher heat, जो primary heat का source है, that will always give out the radiations in the form of short waves. कौन से है short wave radiations? If you look at the electromagnetic spectrum, the electromagnetic spectrum is divided into the short waves to long waves, मतलब in the terms of wavelength. short waves to long waves. So they are starting से gamma waves, उसके बाद एक्स रेज, उसके बाद यूवी रेज, उसके बाद विजिबल लाइट, उसके बाद इंफ्रारेड वेव्स, उसके बाद माइक्रोवेव्स एंड उसके बाद रेडियो वेव्स. So कोई भी light which comes from the sun is basically from this, and as you go from this to this in the spectrum, what you will say is the wavelength increases. Right? So gamma are having the smallest wavelength, उसके बाद X rays, उसके बाद UV rays, उसके बाद visible light. Visible light में भी blue, violet, विबग्योर, इंडिगो, ब्लू, ब्लू के बाद ग्रीन, ग्रीन के बाद येलो, येलो के बाद ऑरेंज, ऑरेंज के बाद रेड. ऐसे है विजिबल लाइट. सो रेड का वेवलेंथ इज लॉन्ग एंड ब्लू का वेवलेंथ इज वेरी वेरी लेस. गेटिंग इट? अब डिपेंडिंग अपॉन द साइज ऑफ द मॉलिक्यूल्स, जिन्होंने जीएस भी किया है, लिसन टू इट वेरी प्रॉपर्ली, बिकॉज ये सब मैं इतना डिटेल में जीएस में नहीं बताता हूं. डिपेंडिंग अपॉन द साइज ऑफ द मॉलिक्यूल्स, डिपेंडिंग अपॉन द साइज ऑफ द एरोसोल्स, द स्मॉलर द एरोसोल्स दे आर प्रेजेंट इन द एटमॉस्फेयर, जितने स्मॉल एरोसोल्स उतना ज्यादा स्कैटरिंग होगा. जितना बड़ा है एरोसोल्स, ऑब्वियसली ऑल आर इन माइक्रॉन्स, उतना ज्यादा अब्जॉर्प्शन होगा. उससे भी अगर बड़ा है एरोसोल्स तो उतना ज्यादा रिफ्लेक्शन होगा. जनरली एरोसोल्स एंड क्या स्कैटर होगा, जिसका वेवलेंथ सबसे कम है, that light will be the scattered the most. So in the normal conditions, as the sunlight is coming and hitting us, and in the normal aerosols which are present, this aerosols will come hit, the light will come and hit the aerosols, and therefore blue light will be scattered the most, and इसलिए हमें हमेशा लगता है sky is blue in color. फाइन. हमारे नेकेड आइज को, नॉर्मल आइज को, जिसकी वेवलेंथ सबसे ज्यादा है, दिस इज ओनली आवर विजिबल रेंज. वी कैन नॉट सी दिस, वी कैन नॉट सी दिस. सो आवर नेकेड आइज कैन सी ओनली रेड फ्रॉम अ लॉन्गर डिस्टेंस, उसके बाद ऑरेंज फ्रॉम द लॉन्गर डिस्टेंस, उसके बाद येलो फ्रॉम द लॉन्गर डिस्टेंस, उसके बाद ग्रीन, एंड ब्लू लाइट जनरली बहुत दूर से दिखेगा नहीं. फाइन. सो इसलिए व्हेन दिस ड्यूरिंग द सनराइज एंड सनसेट, व्हेन द सन इज फारदेस्ट अवे फ्रॉम अस, getting it? Sun is nearest to us when it is exactly overhead, हमारे ऊपर जब होता है during the noon, but during the sunrise and the sunset, sun is farthest away from us. हमारी आंखों को दिखता है सिर्फ ये तीन कलर, और हमें लगता है sky is reddish orange in color. Remember, sky or space does not have any color. वैसे it is dark in shape, right? But it is all due to the aerosols and the scattering of the skies. वाटर वेपर जब प्रेजेंट है हवा में तो साइज ऑफ द एरोसोल्स इंक्रीज. गेटिंग इट? एंड देयरफॉर लाइट ज्यादा बेंड होता है, एंड इसलिए इफ देयर इज मोर वाटर वेपर इन द एटमॉस्फेयर, द स्काई लुक ग्रेइश इन कलर ड्यू टू बेंडिंग. इसलिए हमें लगता है जिस जिस बादल में देयर इज वाटर, हमें लगता है दे आर ग्रे. उनका कलर कुछ नहीं होता है, हमारा आंखों का परसेप्शन है दे आर ग्रेइश इन कलर. गेटिंग इट? It all depends upon the size of the aerosols. Because they are visible, unka wavelength is maximum, because they are visible even from a longer distance. Universal red is the sign of danger. Stop at the red light. Green is the sign of safe. Go at the green light. Blue use ही नहीं कर सकते because blue light scatter करेगा, properly दिखेगा ही नहीं. Fine? This is how electromagnetic spectrum comes to the earth, but mostly the sun rays are dominant in short wavelength, out of which UV rays rarely reach the earth, and Planck's law says that any secondary heat ka body which is heated from the primary heat, for example sun will heat the earth, sun ka wavelength will come in the form of short waves, and the earth after heating will give out long wave radiations. they will give out. So any secondary heat ka body will give out long wave radiations. So earth ka terrestrial radiation is given by long waves, are in the form of long waves. Solar radiations are always in the form of short waves. Greenhouse gases are those gases which will allow the short wave radiations but will not allow the long wave radiations to trap the earth, and therefore they will be trapped inside the earth. Getting it? They will not allow the long wave radiations to escape. Earth generally gives out all the long wave radiations, but earth ka long wave radiations which dominate is infrared. Getting it? So iske karan, because the long wave radiations are trapped inside the earth, especially the infrared waves, therefore the temperature, sensible heat jo hame feel hota hai, it increases, and we say that temperature has increased. So what is the basic difference between the temperature and insolation? Insolation is always in the form of short waves. Temperature is felt by long waves due to the trapping of infrared radiations by the greenhouse gas. What happens to the visible light? Most of the visible light is utilized for the process of photosynthesis. What happens to the radio waves? Earth naturally cannot produce radio waves. Earth naturally cannot produce microwaves. They are produced by some instruments. अगर अर्थ नेचुरली कर लेता रेडियो वेव्स तो सिर्फ रिलायंस, वोडाफोन, टाटा यही कंपनी मोबाइल की कंपनी नहीं होती. हम बात करते और हमें मोबाइल्स की जरूरत नहीं पड़ती. Because radio waves have the longest wavelength, means they can travel the longest distance. So radio waves are very few. जो अर्थ सन का इंसुलेशन comes, जिसके साथ वो रेडियो वेव्स आते हैं, वही रेडियो वेव्स फिर गवर्नमेंट बेचती है इन द फॉर्म ऑफ 2G, 3G, 4G, 5G spectrum. Getting it? So this is what is the insolation. So what are the factors that affect the insolation, and how it is different from the temperature? अब in simple words, whenever you get confused in the examination, याद रखना insolation मतलब धूप. So what are the factors that affect the insolation? Timing of the day, when the sun is vertical or sun is horizontal. Rather than timing of the day, can I say angle of the sun's rays? If the sun rays are vertical, insolation is more. If the sun's rays are inclined, insolation is less. Sun's rays are vertical in all the regions that are located between the Tropic of Cancer and the Tropic of Capricorn. More or less the sun rays will be vertical, and the sun rays will become more and more inclined as you move away from the tropics. Because of the vertical sun rays, heating is greater in the tropics and therefore temperature is high. Understanding everyone? Fine. Secondly, angle of the sun rays also depends upon the position of the midday sun. If the sun is vertically overhead, 12 baje, vertical sun rays. If the sun during the dawn and dusk, inclined sun rays. Getting it? So one is the inclination. Second is, have you realized धीरे से from last 7 days some things are changing. पहले 6:30 को अंधेरा नहीं होता था, अब 6:30 को अंधेरा हो रहा है. Why is this so? Because the length of the day is changing. Why the length of the day is changing? Because the sun is slightly going into the southern hemisphere. 23rd September ko what is there? Equinox. Matlab sun will be exactly over the equator. What is today? 17th September. So 23rd September के बाद अंधेरा और ज़्यादा बढ़ेगा. So second factor that affects the insolation is the which depends upon the position of the sun. and this position of the sun changes due to and revolution on the inclined axis. Fine. How? Give me 2-3 minutes. The third factor that affects the insolation is effects of atmosphere. In the form of absorption by the aerosols of some of the scattering of the particles, reflection, etc. That is, the sun rays will be absorbed by some of the aerosols, will be scattered, generally blue light, and some part will be reflected. And thus, जितना ज़्यादा aerosols or dust particle in the atmosphere, इसलिए हम कहते हैं it is related to global cooling. Sun rays कम हो रही है. Are you able to relate? And the last is, इसी reflection को we will study separately, and this is what is known as albedo. The reflective property of any substance. I am not making you write anything, just try to understand. The reflective property of any substance, when it is expressed in the terms of percentage, is what is known as albedo. That is, how much of the incoming solar radiation falls on the surface, उस incoming solar radiation में से कितना percentage is reflected back into the space as the short wave radiation only, not as the long wave radiation, as the short wave radiation only is what is known as an albedo. For example, out of 100%, अगर 86% is reflected back, then we will say 86% is the albedo. मतलब ये जो 86% which is reflected back will not take place, will not take any role in heating the earth. Heating the earth में जो absorb हुआ 14%, जो absorb हुआ which becomes the long wave radiation, this 14% will only take a part. 86% space को lost हो जाएगा. Understanding? So can I say albedo is an important factor that plays a role in the heat budget of the earth? जो substances जिसका albedo ज़्यादा है, जिसकी reflectivity ज़्यादा है, they will be cooler surfaces. चाहे वहाँ पे polar regions में there is a 6 months of day, still it will not impact. Still we say कि summers वहाँ पे are only for 15 days to 2 months, though they have a 6 months of daytime. It is because albedo of the ice is somewhere around 92%. On other hand, albedo of the sand is somewhere around 40%. Albedo of the black soil is only 10%. That means 10% of the incoming solar radiation is reflected, बाकी 90% is used in heating the earth. Getting it? Are we changing the albedo of the earth? Are we changing the albedo of the earth? How? Melting of ice caps and glaciers, deforestation, urbanization, concretization, roads banana, this all is changing the albedo of the earth. मड्स को आप कंक्रीट बना देते हो, टार के रोड्स बना देते हो which are extremely black in color. You make and cement concrete is just like the earth. Cement concrete will absorb more, reflect less. Fine. Melting of ice caps and glaciers. When the ice caps and glaciers melt, they expose the water below it. As they expose the water, water is now 200 मीटर तो trap करेगा heat को, and thus there will be increase in the global warming. जो जिसको कल के वो notes में था positive feedback loop. Understanding? It was mentioned in the yesterday's this thing. So albedo of the solar panels तो high नहीं होना चाहिए. Why? Because if it is high, तो फिर सोलर एनर्जी कैसे जनरेट होगी? सोलर एनर्जी, इनफैक्ट वहां उसका अल्बिडो और कम करने के लिए उसमें कॉन्केव मिरर्स दिए जाते हैं, सो दैट दे विल पॉइंट इट, एंड दे आर ऑलवेज डार्क ब्लैक इन कलर, बिकॉज जितना डार्क है सब्सटेंस उतना मोर अब्जॉर्प्शन, जितना लाइट है सब्सटेंस उतना मोर रिफ्लेक्शन. बेसिक कंसेप्ट जो हम कहते हैं कि इंडिया में समर्स में सफेद कलर के कपड़े पहनने चाहिए, ब्लैक नहीं पहनने चाहिए, इट इज ऑल बेस्ड ऑन द अल्बिडो. फाइन. Understanding everyone? So these are the 4 factors that affect the insolation. कौन से 4 factors? Inclination of the sun rays, vertical है या the inclined है, horizontal तो exactly नहीं होगा, inclined. Vertical है तो वो कम layers से जाता है, जितना कम layers और कम distance cover करता है उतना less effects of the atmosphere such as absorption, scattering is seen. Plus it is falling on a smaller area, therefore heating up a area more. If it is inclined, it will fall on the larger area. If it is vertical, it will fall on a smaller area. Inclined falls on a larger area, it has to heat up the more surface area. Secondly, jitna inclined means it is traveling a larger distance. Getting it? Or it is traveling a larger distance. इसलिए तो रेड एंड येलो के कलर्स है. जितना लार्जर डिस्टेंस उतना इफेक्ट्स ऑफ द एटमॉस्फेयर इन द टर्म्स ऑफ अब्जॉर्प्शन, रिफ्लेक्शन एक्सेट्रा. सेकंड, लेंथ ऑफ द डे. लॉन्गर द डेज, मोर द इंसोलेशन एंड देयरफॉर मोर हीटिंग. लॉन्गर द नाइट्स, मोर टेरेस्ट्रियल रेडिएशन एंड देयरफॉर मोर कूलिंग. जनरल याद रखो, मोर टेरेस्ट्रियल रेडिएशन, मोर कूलिंग, बिकॉज अभी ग्रीन हाउस गैसेस नहीं बढ़ाए हैं हमने. एक जनरल ज्योग्राफी. थर्ड, इफेक्ट्स ऑफ द एटमॉस्फेयर, एंड फोर्थ इज द अल्बिडो. क्लियर विद दिस? एनी डाउट्स यहां तक? क्योंकि लॉन्ग वेव कैसे होता है? लॉन्ग वेव इज अब्सॉर्ब बाय द बॉडी. अब्सॉर्प्शन के बाद वो हीट अप होता है, और हीट अप होने के बाद एक्सेस हीट जो देता है वो बॉडी, दैट इज ऑलवेज इन द फॉर्म ऑफ लॉन्ग वेव. सो अल्बिडो क्या है? गिरा, अब्सॉर्ब हुआ ही नहीं, और बिना अब्सॉर्प्शन के डायरेक्टली चला गया. रिफ्लेक्शन इज डिफरेंट फ्रॉम रेडिएशन. रेडिएशन मीन्स अर्थ विल अब्सॉर्ब इट, चेंज इट इनटू लॉन्ग वेव एंड देन गिव आउट, दैट इज रेडिएशन. अर्थ ने अब्सॉर्ब ही नहीं किया तो दैट इज रिफ्लेक्शन. हम ये कहते हैं मिरर्स रिफ्लेक्ट करते हैं. मिरर्स कुछ अब्सॉर्ब भी नहीं करते, डायरेक्टली रिफ्लेक्ट करते हैं. हम ये नहीं कहते कि मिरर्स रेडिएट योर इमेज, ये रिफ्लेक्ट द इमेज बैक. फाइन. यस, अल्बिडो में लिखाऊंगा. डिफॉरेस्टेशन depends upon where it is. If the deforestation is occurring in the tropical evergreen forest region, albedo में increase of the earth, because जितना dark green color उतना more absorption, जितना light color उतना more reflection. But प्रॉब्लम क्या होगा? इफ द अल्बिडो चेंज हो जाएगा, ऑब्वियसली डिफॉरेस्टेशन. अगर आप पेड़ कटोगे, यू आर एक्सपोजिंग द रॉक्स. नीचे रॉक बसाल्ट है तो इंक्रीज होगा, नीचे का रॉक अगर सिलिका में ज्यादा है तो डिक्रीज होगा. गेटिंग इट? अल्बिडो इसलिए इंपॉर्टेंट है बिकॉज चेंज इन द अल्बिडो रिजल्ट्स इनटू फॉर्मेशन ऑफ urban heat island. So what is this phenomena of urban heat island? The phenomena of the urban heat island is हमेशा cities का temperature will be 2 to 5 degrees Celsius greater than the surrounding countryside, and this effect is what is known as urban heat island. Understanding the basics? Clear with this everyone? थोड़ा एक mind map बन गया. So insolation. It is a measurement of incoming solar radiation. It is a measurement of incoming solar radiation expressed in watts per meter square. Expressed in watts per meter square per day. Per day. डायरेक्ट इंसोलेशन, देखो अगर सब कुछ प्रिंटेड नोट्स में होता तो नहीं लिखा था, जीएस के नोट्स तक यहां तक ठीक है. इंसोलेशन क्या है? ऑप्शनल में डायरेक्ट इंसोलेशन is slightly different from insolation. Direct insolation is the difference between solar constant direct insolation is the difference between solar constant what is solar constant? कितने रेज सन के सरफेस से निकले हैं, that is the solar constant. Fine, solar constant. And the insolation, difference between solar constant and the atmospheric losses, and the atmospheric losses caused by absorption and scattering. And scattering. क्या है डायरेक्ट इंसोलेशन? नेट जितनी अर्थ पे आ रही है. फाइन, यू कैनॉट चेंज सोलर कांस्टेंट. सन, चाहे आप यहाँ पे न्यूक्लियर बॉम्ब फोड़ो, डिफॉरेस्टेशन करो या ना करो, सन तो उतनी एनर्जी देने वाला है, वो चेंज नहीं हो रहा है. ग्लोबल वार्मिंग के कारण नेट जो आ रहा है दैट इज चेंजिंग बिकॉज यू आर डूइंग मोर पोल्यूशन. सो इसलिए there is more absorption because of the presence of aerosols, and therefore direct insolation में reduce या increase. Getting it? So deforestation से क्या हो रहा है? Direct insolation increases या decreases? क्या होगा? Deforestation से direct insolation increase होगा. Why decrease? Now there is no tree, direct insolation has increased. Getting it? No, you are confusing there. डायरेक्ट इंसोलेशन मतलब ग्राउंड पे कितना आ रहा है, ट्री पे नहीं. ट्री इज अब्सॉर्बिंग, अब ट्री नहीं है तो अब्सॉर्प्शन कम, इंक्रीज करेगा. अच्छा, आई थॉट यू आर सेइंग डिक्रीज. नेक्स्ट, solar constant is the rate at which solar energy reaches the earth's surface, is the rate at which the solar energy reaches the earth's surface and is 1388 watts per meter square. watts per meter square. इसी को एनसीईआरटी ने दिया है टू लैंगलेज पर मीटर स्क्वायर. फाइन, सो कुछ भी एक वैल्यू लिख सकते हो, टू लैंगलेज या 1.388 पर मीटर स्क्वायर. लैंगले यूनिट चेंज हो गया इसलिए वैल्यू चेंज हो गई. फाइन, लैंगले दिस इज मेजर्ड इन वैट्स, लैंगलेज इज मेजर्ड इन कैलोरीज. फाइन. नेक्स्ट, diffuse insolation reflects to, diffuse insolation reflects to the insolation that is reflected, the insolation that is reflected in the sky, the insolation that is reflected in the sky. मतलब diffuse insolation is nothing but when you measure it from the earth you call it as albedo. जब आप ऊपर अगर मेजर करोगे कि कितना आ रहा है उसको आप कहोगे एज अ diffuse insolation. Understanding? Reflected in the sky. नेक्स्ट, पॉइंट ऑफ रेफरेंस फर्क है बस. कितना रिफ्लेक्ट हो रहा है फ्रॉम द सरफेस, अल्बिडो. कितना आ रहा है वापस एट दैट सरफेस, तो उसको हम कहेंगे डिफ्यूज. गेटिंग इट? पॉइंट ऑफ रेफरेंस फर्क है बस. इंसुलेशन डिपेंड्स अपॉन न्यूमरस फैक्टर्स such as angle, of the sun's rays, angle of the sun's rays, vertical, more insolation, क्लियर? डिक्टेट नहीं करा रहा हूं. वर्टिकल, मोर इंसोलेशन. इफ यू वांट यू कैन टेक दिस डायग्राम. इंक्लाइंड वाई देयर इज लेस इंसुलेशन, बिकॉज एरिया बढ़ जाता है, बस सरफेस एरिया बढ़ जाता है. सेकेंड, स्फेरिसिटी ऑफ द अर्थ, or spherical shape of the earth? इसके अंदर spherical shape of the earth, इसके अंदर क्या है? ट्रॉपिक्स, more insolation. Why more insolation? Because it is vertical and comparatively nearer to the comparatively it is more near to the earth, near to sun. Polar regions, insolation is always inclined and less. Because sun's rays travel longer distance. Clear है? Just look at the shape. जो सन के पास है वर्टिकल, जो सन से दूर है एंगल बढ़ते जा रहा है. फाइन. इसीलिए इन द हायर रीजन्स तो 6 महीने का दिन 6 महीने की रात होती है. इन दैट 6 months ऑफ डे डायरेक्ट इंसोलेशन बहुत कम होता है, इसलिए दिन भी ऐसे लगता है शाम के समय जैसा. इट इज नॉट दैट वेरी स्ट्रॉन्ग बिकॉज देयर इज मोर ऑफ एन डिफ्यूज सनलाइट देन डायरेक्ट सनलाइट. फाइन. दैट इज सनलाइट दैट इज लॉस्ट बाय स्कैटरिंग एंड रिफ्लेक्शन, वो ज्यादा है. थर्ड, transparency of the atmosphere. Transparency of the atmosphere. Transparency of the atmosphere. इसमें लिखना atmospheric particles and water vapor दोनों, atmospheric dust particles and water vapor absorb reflect refract the insolation and fourth length of day. Longer days, more insolation, and therefore more heating. And fifth is albedo. Is nothing but the reflective property of the earth. Fine. Before I go further, temperature क्या है? जो heat हमें feel होती है. So अभी question आप answer कर सकते हो, what is the difference between insolation and temperature? 150 words में. What is insolation? Incoming solar radiation which comes as a solar constant. It depends upon the following factors. This insolation, depending upon the weather conditions, presence or absence of the clouds, forest or no forest, will be used to heat up the earth. The earth, after heating up, gives out long wave radiations which are then captured by the atmospheric gases. This long wave radiations will help in increasing the temperature of the earth, driving the weather patterns. So this sensible heat which is caused due to insolation is what is known as a temperature. Insolation does not result into any weather phenomena, but all the weather phenomena are done by temperature. Temperature we feel is due to the long wave radiations. Getting it? Insolation का हमारे इसमें ज़्यादा संबंध नहीं है. Insolation वही interested है जिसको solar energy बनानी है. इसलिए initially the International Solar Alliance was open to only those countries which are located in the tropics. Right? वो इस पे डिपेंडेंट नहीं था कि साइबेरिया में समर्स में तो बहुत ज्यादा गर्मी होती है, तो फिर रशिया को भी ले लो एज अ पार्ट. आपको गर्मी से लेना देना ही नहीं है. You are the solar energy is based on the insolation, right? Not on the heat. Garmi is temperature, dhoop is insolation. What? Insolation has? Insolation obviously will be heating up, but it won't be as great as temperature. See, for example, on the cloudy days you will feel more hot as compared to on the non-cloudy days. Why? Because heat is obviously seen in the form of long wave radiations. Which day is more hot? The day with the cloud cover or without cloud cover? With the cloud cover. Why? Because water vapor is a greenhouse gas. It traps the heat. Fine. Albedo. Albedo. And do this albedo very properly. Albedo is the reflective property of the earth. Is the reflective property of the earth. Full stop. It determines how much of insolation, insolation or incident radiation. Incident radiation is nothing but insolation. Incident radiation is reflected directly back into the space. Is reflected directly back into the space. Without taking part in the heat budget of the earth. Without taking part in the heat budget of the earth. It is generally expressed as percentage. It is expressed as percentage. It is expressed as percentage. It is expressed as percentage. The albedo of the lighter objects. The albedo of the lighter objects is greater the general table of albedo is as shown. The general table of albedo, ये मेंस में बनाना और ये प्रीलिम्स के लिए भी याद रखना. The general table of the albedo is as shown. I'm just, you can just write deciduous forest also. मैं थोड़ा और डिटेल में दे रहा हूँ. Albedo will go on decreasing. Cirrus clouds, because they are made up of snow, उनका albedo is 96%. Fresh snow का albedo is 92%. Ground snow, old snow कितना काला है कितना सफेद है डिपेंड करता है 84 to 90%. Desert soil का albedo is 40 to 60%. Grassland का albedo is somewhere around 40 to 45%. क्योंकि उसमें ट्री कवर कम है. Temperate deciduous forest का albedo is 35%. Tropical deciduous forest का albedo is somewhere between 25 to 35%. तो इतना factual data आपको याद नहीं रहेगा. So I'm not making you write. Tropical evergreen forest का albedo is 15 to 25%, depending upon ज़्यादा dense, less albedo, more absorption. And black soil का albedo is only 10%. Fine. क्लाउड्स का जनरल 27%, डिपेंडिंग अपॉन कौन सा क्लाउड है वो वेरी करेगा. 94 to 10% cumulonimbus. So क्योंकि clouds will change color with the height. Next, this variations in the albedo causes variations in the temperatures. Understanding? क्यों variations in the temperature? जितना absorb हो गया उतना heating, and heating is temperature. In general, the albedo of the earth, the albedo of the earth goes on increasing from equator towards the poles, whereas the insolation goes on decreasing from equator towards the poles. Insolation goes on decreasing from equator towards the poles. Albedo has an important bearing on global pressure belts, wind circulation, global pressure belts, wind circulation and oceanic gyre, मतलब ocean currents and the oceanic gyre. And therefore, due to the melting of ice caps and glaciers, due to the melting of the ice caps and the glaciers, as the albedo of the earth is decreasing, as the albedo of the earth is decreasing, the direction and the intensity of the winds is changing. Winds is changing, sea level is rising, sea level is rising, threatening both polar as well as tropical regions. Threatening both polar as well as the tropical regions. Fine. I'll stop here. Tomorrow we'll start with the temperature. वो जो क्वेश्चन है इंसोलेशन वर्सेस टेम्परेचर थोड़ा सोच के आना, बिकॉज इतना डेटा है उसको लिखोगे क्या 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 लिखोगे और क्या क्या नहीं लिखना है. I'll also give the landforms ka handout tomorrow because it is now ready with me.